Hello friends, in today's lecture I am going to discuss another most important type of mathematical logic, that is predicate logic. And in my previous videos I have discussed the another type, that is propositional logic, and in this video I will discuss what do you mean by predicate logic and its various types and how to represent predicates. And before discussing predicate logic, let's discuss how predicate logic differs from propositional logic and what is the importance of predicate logic, why it is required, why it is used in the context of mathematical logic. So the propositional logic that we have studied earlier is not powerful enough to express all kinds of mathematical statements. So let's take an example. If we are having a statement x is greater than 5, so this particular statement or sentence is not a proposition, as we have already discussed, because x is a variable here, and x, until we assign any value, any constant value to x, we cannot say this particular sentence is either true or false, so it is not a proposition. So if we look carefully at the mathematic history, such kind of statements are most commonly used in mathematics, such as x is greater than 5, x is equal to 7, x is not equal to y, and so on. To deal with such particular equations, a more powerful logic is required, which is known as predicate logic. So the meaning is propositional logic cannot deal with such kind of statements, and to deal with such particular statements we require a more powerful logic that will overcome the disadvantage or drawback of propositional logic, and this particular logic is known as predicate logic. So let's discuss what is predicate logic. So any logic which deals with predicates and quantifiers is known as a predicate logic. Now what is predicate? A predicate is any verb phrase or any template that describes the property of any object or relationship among objects is known as a predicate. So predicate in a sentence is nothing but simply a verb phrase or any template which describes the properties of individuals or which creates the relationship among the various objects. And the best part of predicate logic is that it always talks about the generalized form rather than the specific form, because if we take any example of any proposition, that is 7 is greater than 5, so that particular proposition is always discussing about the 7, that is the constant value, but predicate will be x is greater than 5, so that will be the generalized form. Any value can be put in the place of x to compare it with the value of 5. So that's why predicate logic is more powerful, more commonly used as compared to propositional logic. And let's take some of the examples of predicates. So here we are having two different sentences: Nadal plays tennis and Federer plays tennis. So if we look carefully in these two sentences, plays tennis is the common sentence, is the common words. So this particular common words are predicate, because this particular sentence or words describes the property of two different persons, two different individuals, and we can replace the individual name with the variable x, and it can be rewritten as x plays tennis. So the complete sentence x plays tennis will become a predicate, where x can be any individual, any person who plays tennis. And let's take some more examples to understand predicate. Cat is an animal, dog is an animal. So again, is an animal is common in both the sentences. So this particular verb phrase, this particular template is a predicate. Some more examples are x is greater than y. Now look carefully, here we are having two different variables, two different objects, and is greater than is giving us the relationship between these two objects. So is greater than here in this particular sentence is a predicate again. And some more examples are P is married to Q. So is married to is again our relationship between these two objects P and Q. That's why is married to is a predicate. And just like propositions, predicates can also be represented by symbolic names, and if we remember, the propositions are generally represented by lowercase letters, but in the case of predicates are generally referred by the uppercase letters, the capital letters P, Q and R and so on. And the variables x, y and z are the individuals, objects or variables which are used in that particular predicate. So for example, we are having a predicate p of x which says x is an odd number. So here capital P is the predicate and x is the individual object or element or variable which is used in this particular predicate. Similarly, there can be more predicate which involves more than one object. So here two different objects x and y are used and the predicate name is capital Q and the predicate says x is the perfect square of y. So if we look carefully in this particular statement, in this sentence, two different objects are used, and similarly in the last example we have used three different objects, three different variable to denote this particular predicate. And if we talk about the various types of predicates, so predicate can be one place predicate. So one place means it involves only one object or one element. So if we denote any predicate by capital P and P of x is a prime number. So if we look carefully in this sentence, only single object is used, only single variable is used, so that's why it is one place. And two place will involve two objects such that x is a friend of y. So is a friend is predicate and it is denoted by q of xy, and if we look carefully both x and y are used inside the statement and two objects are used, so that's why it is two place predicate. Similarly, we can have three place, four place and so on. And if we talk about the generalized form, so n place predicate is a predicate that involves n objects or n elements. So suppose capital R is another predicate which involves four different objects and it returns the summation of u plus v equals to w plus x. So here n equals to 4, so this particular predicate will become four place predicate, and so on. We can generalize it up to any number of terms. And the next important thing in predicate logic is universe of discourse. So without understanding this particular thing, you cannot learn predicate logic. So universe of discourse is one of the most important aspect of predicate logic, and it is also known as universe, and it is denoted by the letter capital U. So what is universe of discourse? Out of all possible objects, the objects which are of our interest, the set of those objects in which we are interested, we want to take for that particular predicate is known as universe of discourse. Or we can also define universe of discourse as the domain of allowable values for a particular object, and this particular universe of discourse definitely varies from different sentence to different sentence. So let's take an example to understand what is universe of discourse. Suppose we are having one predicate which is denoted by capital P of x, that is x is greater than 3. Now look carefully, we know that we are comparing the value of x with any number, with any integer. So here x cannot be any color, it cannot be any vehicle, it cannot be any person, and x has to be definitely from either the integer value or real number. So the universe of discourse for this particular predicate, or we can say the universe of discourse for this particular variable x, will definitely be the set of integer or set of real numbers. So if we talk about this particular predicate, we will only choose from the set of these two integers or real numbers. We will not talk about the colors, we will not talk about the persons or anything else. And one more example to understand universe of discourse is, let q be any predicate having three objects. So the predicate says x was born in city y in the year z. Now if we look carefully, x has to be from the set of human beings. So from the sentence it is clear that x is any human being and it cannot be anything else. Similarly in city y, so the sentence says x was born in city y, so definitely y should be any city, it cannot be human being or it cannot be any year. And similarly the universe of discourse for the variable z has to be from set of years, it cannot be human being or it cannot be anything else. So from the statement it is clear that this particular sentence has three different objects x, y and z, and all three objects x, y and z are having their own universe of discourse. From those particular set we can put any value to these three individuals. So x cannot be any year or any city, y cannot be any human being or any year, and the z cannot be any human being or any city. So for every individual, the set of allowable objects, the universe of discourse is predefined if we are talking about the predicate. So this is all about the introduction of predicate logic and various types of predicate logic. In the very next video, I will discuss a very important topic, that is quantifiers. Thank you.